Hi everyone. Today, we're going to take a quick journey through the history of numbers. Numbers are all around us, but did you know they've been used for thousands of years? Let's go back in time and learn how people first started using them. First, let's talk about the Sumerians, who lived a long time ago, around 1900 to 4500 BCE. They were one of the earliest civilizations, and they came up with an important idea: numbers. The Sumerians used a special number system called hexadecimal, which means they counted in groups of 60, instead of 10 like we do today. This was different from our regular counting system. To help with their counting, the Sumerians used objects like small stones, beads, and cones. Each object stood for a different number. For example, one object might mean 1, another might mean 10, and some represented even bigger numbers like 60, 600, and 3600. This way of counting was really important because it helped the Sumerians keep track of things like trade, the time, and even the stars. And guess what? Their system influenced many future number systems, including the one we use today. So, even though the Sumerians lived a long time ago, their idea of numbers helped shape the world we live in now. Isn't that cool? Hey there! Did you know that the Egyptians used a special way to write numbers over 3,000 years ago? They had a number system based on 10, just like the one we use today. When they wrote numbers, they started with the largest value first. So, for example, to write the number 2525, they would start with 2000, then put 500, followed by 20, and finally 5. It's like how we write numbers today, but with their own cool symbols. Now, let's talk about Roman numerals. A long time ago, from around 500 BCE to 500 CE, the Romans used Roman numerals to count. This system was used all over Europe until the Middle Ages. The Romans needed a better way to count, especially when numbers got bigger than 10. Counting on fingers just didn't work anymore, so they created the Roman numeral system. Roman numerals use just 7 letters to represent numbers. I stands for 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. So, next time you see a Roman numeral, you'll know what it's all about. Hey everyone! Did you know that the concept of zero was invented by the Indians between 500 and 1200 CE? This was a huge discovery that changed math forever. With zero, the Indians created the decimal system, which is the number system we use today. Indian mathematicians made many important contributions to math, but the invention of zero is the most important one. Without zero, math wouldn't be the same. The number system we use now is called Indo-Arabic numerals. This is because the Indians invented it, and later, Arab merchants took it to the Western world. Pretty cool, right? Let's talk about some cool math history. In the 9th century, a mathematician named Muhammad ibn Musa al-Khwarizmi made a huge contribution by creating algebra as its own subject. Before him, math was mostly about numbers, but he introduced new ways to think about math problems. Other mathematicians, like al-Karaji, took his ideas even further, making math even more advanced. These discoveries spread to Europe and helped Western math grow. So, the math we use today is also influenced by these early ideas from the Islamic world. Now let's jump to the modern era, which started around 1700. In this time, people created new number systems like the binary system, which is used in computers, and the hexadecimal system, used. In coding, the number system we use today, called the decimal system, comes from the Arabic numbers. This system has been developed over thousands of years, starting with the ancient Sumerians. In the modern era, we started using the numbers we count with, 1, 2, 3, and later expanded to include real numbers, which are the numbers we use every day. Let's talk about two types of numbers, rational and irrational. Rational numbers are numbers that can be written as fractions, like 1/2 or 3/4. We call this set Q. Irrational numbers are numbers that can't be written as fractions, like pi, 3.14, or the square root of 2. We call this set Q dash. Now, all real numbers, which we use in everyday life, are either rational or irrational. So, we combine both sets, Q and Q dash, to get the set of real numbers, which we call R. So, R equals Q union Q dash. Next, we're going to learn about numbers, specifically real numbers. Imagine the real number world like a big family with lots of cool cousins and siblings. Ready? Let's dive in. First, we have the real numbers. That's the whole family. These numbers can be split into two main branches, rational numbers and irrational numbers. On one side, we have the rational numbers. These are numbers you can write as fractions, like 1/2 or 3/4. But wait, there's more. Rational numbers can have two special kinds of cousins. First, we have terminating decimals. See this number. 0.5 is a terminating decimal. It's like a stop sign. There's no more after the 5. It just ends. So, numbers like 1/2 or 3/4 are rational and they turn into neat, easy to read decimals. Then we have non-terminating, recurring decimals. This is when the decimal never ends, but the numbers repeat, like 1/3 turns into 0.333 and so on, where the 3 keeps repeating forever. It's like a song that keeps playing the same beat over and over. On the other side, we have the irrational numbers. These numbers are a little different. They can't be written as neat fractions. They go on forever without repeating, like pi or square root 2. They never stop and never repeat in a pattern. Check out pi. It starts with 3.14159, but then it keeps going and going. No ending, no repeating. So, these numbers are irrational. So, here's the cool thing. All of these numbers live in the real numbers world. Some are easy to work with, like rational numbers that either stop or repeat. And some are mysterious, like irrational numbers that just go on forever, without any repeats. Isn't that awesome? Now, you're ready to be a number explorer and understand how numbers behave. The next time you see a number, you'll know whether it's rational or irrational. Keep exploring, and math will always be a fun adventure. Next topic is decimal representation of rational numbers. Let's talk about terminating decimals. A terminating decimal is a decimal number that has only a few digits after the decimal point, and it stops. For example, 1/4 is 0.25, 8/25 is 0.32, 3/8 is 0.375, and 4/5 is 0.8. All of these are terminating decimals because they stop after a few digits. Now, let's talk about non-terminating and recurring decimals. These are decimal numbers that go on forever, but they repeat a pattern of digits after the decimal point. For example, 1 divided by 3 equals 0.333 and so on. The 3 repeats forever. 1 divided by 6 equals 0.1666 and so on. The 6 repeats forever. 22 divided by 7 equals 3.142857 and so on. The pattern 142,857 repeats forever. 4 divided by 9 equals 0.444 and so on. The 4 repeats forever. Even though they go on forever, these numbers are still rational because we can write them as fractions. These numbers never end but repeat in a pattern, and they are still rational numbers because they can be written as fractions. Now let's talk about irrational numbers. These are decimal numbers that go on forever and never repeat a pattern. They don't stop, and the digits never repeat in the same way. For example, pi equals 3.14159265358979932 and so on. It goes on and on without repeating. E equals 2.7182818284590 and so on. Also goes on forever. The square root of 2 equals 1.41421356237309 and so on. This one never ends and doesn't repeat. These are all irrational numbers because their decimal parts never end or repeat. Remember, E is called Euler's number.